All right, welcome back. We are Game 3001 in the winter 2021 semester, and it is week 8, part 2 of our broadcast. This time we're doing our lab number 6, and Ethan's asking if we're going to be on GitHub. Yes, it'll be on GitHub. And let me show you where to start. So we're starting here, lab 6. There is a lab 6 starter. If you can please use this as a starting point. This is just lab 5 where we're going to jump off from, and we got some stuff to clean up from here and start a brand new project. So please download that first. And I've already done that. Let's talk about, while you're doing that, let's talk about what we're going to do with this lab. What are the goals? So lab 6 goal is we're going to develop a line of sight system, as it is fundamental to both assignment 3 and assignment 4. We're going to use a line-line intersection test and line-line or line rect intersection test to perform this check, this line of sight check. There are other ways to perform this, but this is probably one of the easiest ways to understand for you, since we already have these tests inside of our assignment framework. Future labs will include some algorithm improvements where we might include things like line circle intersection tests, which will not be included in this lab, as well as using Bresenham's line algorithm to create raycasts. All right, so there's a little bit of a theory there from on Wikipedia, actually, if you want to look at it. But we're going to probably do that, and which makes it a little bit more reasonable, more accurate to do it this way. But we're not going to do it accurate today. We're just going to make it work. Remember that one thing we want to try and do is make it work, give us a reasonable system that is understandable for you guys to use, and then we'll move into something more challenging and more interesting as time goes on. And so, like I said, line of sight is fundamental, and that's why we're starting with that. So again, what I want to do here is I've downloaded the project, and I've created Lab 6A and Lab 6B. You guys are the B team, and I'm just going to launch Lab 6B from here. Hopefully you guys got the starter going as well. So going to Lab 6B, double clicking, and bringing up Visual Studio, and here we go. Remember, for your labs, just as a reminder for those people who are watching this remotely on YouTube, what I've been asked to do from Alex is please make sure you hand in your screenshots. No screenshots, no marks, is what Alex basically said, and I agree with that. Same thing with your, not just your GitHub repo, but also please don't hand in videos. Apparently videos are long to look at. I agree with that. So just make it simple, keep it simple for all of us. Okay, I've downloaded the project. I'm just going to switch from x64 to x86. This is switching off the, kind of the platform type. And then what we want to do is test this out to see what we've got so far, and then I'll put it up on GitHub. So first, what we have from last time is a very simple pathfinding kind of example that you guys use. Some of you guys use almost the exact same thing in your assignment. That's fine. Some people did too close to what I gave you in the assignment or missed stuff, and that's fine. So here's this. And then what we did was we said, look, if I move if I kind of turn on my my grid, you can see this is the grid. This is what we did last time. And then we want to find the shortest path depending on the type of algorithm that we want to use. As an example, I want to find the shortest path, and then it'll show us that algorithm. So that's what we did, but we don't need all that stuff right now. We can erase a lot of it, and that's what we're going to do next. But first, let's put this up on GitHub. So again, I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. One more thing we have to do before we do this is inside my Solution Explorer under Docs, let's make sure that this reads properly. It should say Lab 6, not Lab 5. That's one thing. I'll save that. It's a change. And then under Team Explorer, we'll go to Add Solution to Source Control over here. So we can go to Solution Explorer, right-click on my solution, and go to Create Git Repository right here. That's going to be like doing a Git init. All right. I'm going to give that to you in a second, Ethan. Right. It is on Blackboard, but I'll give you the kind of where I'm going to go with. Blackboard has the starter. If you look at Blackboard, like we said before, the starter is right here, Lab 6 starter. That's where we're starting from. And that's where you should start from. And then if you need to kind of compare my code with your code, you can go after this. I'm going to post another little link here that's going to show us everything else. Okay, let's continue. So yeah, I've got this, and I've initialized everything. I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Sync, and I'm going to go to Publish to GitHub, and it's going to ask me to put it on the proper account. I'm going to go to George Brown, and where it says Lab 6B, this is where it's going to be published. I'm not going to make it private, but you would, and click Publish. So this is where you can compare your code to my code. Okay, I don't expect you to hand me back the same thing. You'll get 0 marks for that. All right, so don't give me my code back. You should try it on your own. All right, so let's do this. I'm just going to go up on GitHub now, and you can see that I've got Lab 6B, and that's going to be our final. So grab that, go into here, Content, and then I'm going to add a new link, and this will be the Lab 6 final. All right, so this will be the final version as an example of what it's going to look like at the end. There we go. All right, and let's get moving on this one. So what I want to do is I need to clean up this thing, because this thing has a bunch of stuff from our pathfinding examples, and we don't care about pathfinding right now. So we're going to kill a lot of the work we did in the last times. All right, so let's go back, go over here, and go to our placing.h and start doing some removals. So the first thing I want to do is get rid of anything that has to do with pathfinding, because we're not doing pathfinding today. So everything from basically where it says pathfinding down, all this stuff is gonzo. So see you later, all this stuff pathfinding. Bye-bye. And this is going to create a bunch of errors for me. In the meantime, what I also want to do is, as I'm going I'm working on my .h file, let's also add an obstacle pointer. So I want to add in the obstacle, but remove the other stuff. Okay, so that's one thing I want to do. I don't need heuristic.h, that's for sure, or tile.h. Let's get rid of that. But we can leave button for now. Okay, so that's where our .h is looking like right now. I've kind of made it a little bit more anemic. Why? Because I really don't need any kind of pathfinding stuff whatsoever. Pretty simple. All right, let's fix all the errors now that appear in placing.cpp while we clean stuff up. So you can see there's a pile of errors now, right? And that's how it should be. So in our update, we want to kill this part. While we're up here, we know there's a bit of a bug when it comes to drawing everything in IMGUI. We're just going to move this draw display list down to just below the if statement here inside of our draw function, which will kill the bug in IMGUI for us because we don't care about a grid. There we go. Okay, so that is that. And I'm going to scroll down and start killing more of these errors. So any place you see these errors, just delete this stuff. I'm going to leave these inputs for now because maybe I'll use them later, maybe another time. Build grid, I don't need build grid, so let's get rid of all the grid stuff related things. I do need my ship, but my ship is not going to transform position to a tile. There is no tile, so get rid of all this stuff in the ship. And the same thing with my target. I'll add some stuff in there. We don't need to compute tile costs. That doesn't matter anymore because we're not doing tiles whatsoever. And in the GUI functions, it says the checkbox for the grid enabled. We can get rid of that for now. And heuristic stuff with the label heuristic type, blah, blah, blah. We can get rid of all that. And maybe a separator too. Get rid of that too. But we'll maybe leave that separator back in there. I might need another little bit of separation there for something else. In the start position code, we don't care about any of this. So let's get rid of all this stuff. And same thing with the target position. We'll fix this up in a sec. We don't need the shortest path. We can get rid of this whole statement. And yep, that's good. And we don't care if it's moving or not. Okay, so that's all the stuff we get rid of there. In the build grid, there is no build grid, so we're getting rid of all this stuff here. Literally just deleting all of it all the way down to the bottom where we don't need any of this stuff. This is all the stuff we added in for our pathfinding. We'll just get rid of that, and that's everything gone. And that should be our start. Okay, so I got you guys to do that to get you to understand all the things we did also for our last time. I mean, I could have started with that starter, but I figured we'd do it together. All right, so that is a clean slate, if you will. Let's add some additional things inside of our start scene now. We want to say that m_p ship is the transform dot position is going to be equal to a glm vec2 object that is going to be kind of on the left side of the screen. So we're going to start our ship on the left, and we're going to have our obstacle in the middle, and then we're going to have our target on the right. All right, so that's how we're going to do it. So again, on the left, that would be at, let's say, 200 on the left side. It's an 800 by 600 screen, 300 on the y-axis. That's going to be putting up to the left of center. Okay. Similarly, I'm just going to grab this and copy paste. And similarly, what I'm going to do is I'm going to start the target on the right side. So around 600 pixels. 600 pixels on the right. And then what I want is in the middle, I want to put my obstacle. So my obstacle is going to be here. m_p obstacle is equal to a new obstacle. We've defined an obstacle as that green box. So that's where this is going to be. And the obstacle is going to be in the exact center of the screen. So again, it's 400 on the x-axis and 300 on the y-axis. So you notice these are all the same. And we got some other things to clean up. But for now, let's just test this and make sure we have on the left side, we have a ship. On the right, on the middle, we have an obstacle. On the right side, we have a target. Let's see if we can get that going right now. And I'm doing it quick so that way we have more time, because this can last a while if we don't have everything working properly. And yeah, like this. This is what you should have. Okay, so kind of left side, middle, right. Okay. And so really what we're doing with this is, what we're trying to do is for today is we have a ship. Let's suppose we have a ship that's square-ish. We have a rectangular obstacle, and then we have a target that is round, square, or circular is the better way to say it. And we're going to cast a ray. That's what we're going to do, which is just a line segment that comes from the center of the ship through the obstacle to the center of the circle, like so. That's what we want to do. And if this is the case, the line is going to be red, which means no collision. However, if I move things around, if I rotate the ship or whatever, and let's suppose my obstacle is up here, right? So let's say my obstacle is up here, and I rotate the ship so it faces where it's shooting its ray, then I should be able to do, let's do something like this first. Let's make this black as well, and let's put the obstacle outside of something you can see, and then we'll change this back to red so we can shoot the ray. So if I shoot the ray here, as an example, then we don't want to have a red ray. We want to shoot a green ray, or a green line, line segment, that's going to come out here, because this is line of sight. This has no line of sight, right? So just to define what that means. So this is line of sight, right? And this is no line of sight. So line of sight. I'm going to cross that out. No line of sight, right? That's what we want to do. I want to make it so that I can move my target, which is this part, right? That's what I want to make it do. So this is my target. And I want to move my my ship, which is my start. I want to move both those two things anywhere on the screen. And I want to be able to rotate the ship in any direction. Okay, that's what I want to be able to do. So Ethan says, so we create a line from ship to target and check if the line intersects with an obstacle. Kind of. What if, and this is the thing when it comes to intersection, without doing any fancy algorithms, let's think this through. What if I have this line? Does the line know that it's kind of intersection with both the obstacle and the target? The line does not know this, right? It knows that it's going to do an intersection test with whatever you give it. So, for example, if I want to do an intersection test with the line and the obstacle, that's a line rect test. If I want to do an intersection test with the line and the target, that would normally be a line circle test. Today, we're just going to choose the target as, even this target is going to be squarish. We're going to draw a bounding box around this thing because we're not going to use line circle detection. I don't have that code in play. I will put that in play another day so we can do a more accurate detection. But more or less what's going to happen is you're going to have an imaginary kind of like a bounding box that surrounds the circle, and that's how it's going to do its line rect check. So it's going to be a line rect check. And the way line rect checks work is it takes a line-line intersection for each line inside the rectangle. So for example, there's a line here, right? There's also a line here. There's a line here. And there's also a line here. So whenever you do a line rect check, it checks all 4 lines with this line, right, to do an intersection test. That's how it normally works, okay? So similarly, we're going to do the same thing with our target. We're not going to do a line circle check, although that would be the easiest to do, right? So that's the situation. That's how we're gonna target stuff. We're gonna see if there's a line, you know, here and there, and if we move things around, we're gonna get these list difference in lines. So first things first. Ethan says, so in theory, if you had a line that started and ended inside the obstacle without touching the edges, the direct collision wouldn't work. Theoretically, yeah, because that mean you have a line and not touching any of the obstacles. But if the line intersects with one of the edges, you're good to go. Okay. All right, so that's nice. Excellent. Let's fix some of these classes. We know that last time we had a navigation object as opposed to just a display object for both the ship, a navigation object, as well as the target navigation object. Let's make these back into display objects because we don't need them to be navigation objects. I'm not going to kill the navigation object class, but I don't need it anymore. And I'm going to drag in. I'm going to save this. And same thing with my ship. I'm going to change this to display object and change the reference to display object here because we don't need to do that. Anything to do with grids. That's why I'm changing it back to display object. Okay. So just lightening the load a little bit. And then I want to take my ship and my target and drag and drop them back into the game objects class, filter. And the only thing I have in my navigation now is my tile because I don't care about anything else in it. Okay, so I just removed the navigation class is all I did. I backed it up. Okay, so excellent. We've done that part and I like it. Now what we want to do to start testing is in my ship.h and my ship.cpp. I want to be able to do draw the line that I want to cast. So again, I think one of the challenges that we have when it comes to thinking about this stuff is how to start. All right. So here in my ship.h, we have a change in direction and so on, and a current heading and a current direction and a target position. Let's start prepping for stuff for line of sight. So for line of sight, ship needs a little bit more information, right? So what I want is a float that is the m_ line of sight distance. So we're going to have a maximum distance for line of sight. That can be something you set. We also want to have a Boolean that is m_ has line of sight, something that basically, can keep track, do we have line of sight or not? And I also want to have a special color, which is going to be a vec4 actually, which is going to change my m_ line of sight color, except I don't have a vec4 object right now. What I need to do there is I need to include I have a new include here for GLM. So we're going to say that glm/vec4.hpp. Okay, so that is going to be the vec4. A vector 4 is a 4-dimensional vector, which includes R, G, B, and A. So for our color, all right? Again, you don't have to do it this way, but I'm choosing to. Yay, so some properties that we want for this one, right? We also want a few additional getters and setters. Let's start doing this. Again, just in prep for everything that we're doing. So I'm going to go with a couple of getters and setters. So one of them is a float that is get line of sight distance. We want to be able to get the line of sight distance outside of the class, as well as a Boolean that is a has line of sight. Do I have line of sight or not? I want to be able to kind of check to see if the ship has line of sight. Okay, so those two getters. And I also want to do the same thing with the setters. I want to say that I want to set somewhere. So void set line of sight distance. If I want to set it from outside of my class, where I take a float distance. And then the same thing goes with a void set has line of sight, where I have a bool and I give a state of if it has line of sight or not. One thing that I also found when I was doing this, the first lab, is I can detect, I can get my current direction, but I can't get or set the current heading, which is the angle. So let's get those two things as well. So I'm going to say that I want to make a getter, which is going to return a float of my get current heading. Again, I'm just adding these new things into the ship class to support the things we're going to do, as well as let's add a setter for void set current heading. So those are the things that I want to be able to do, where I pass in a float, whatever the new heading is, and I want to be able to do that. So those are the things I want to start with to support the new stuff. So I've added 6 declarations, and I want to basically, kind of implement these declarations. All right, so let's do that. So save everything. And again, I'm going to go up to ship, and it's going to say generate definitions by declarations. I'm using ReSharper here, and it says get and has line of sight, get and, kind of detecting. And then get current heading, set line of sight distance, and set has line of sight, right? So I'm just doing all this stuff here, right? And this has line of sight, really should be get has line of sight, but I'm just keeping it like this. Okay, and finish. So what this is going to do is going to declare all those things in sequence for me, which is going to make my life a lot easier to code. So let's code all those things. So one thing is, let's start with get line of sight distance. It's just going to be, we're returning it out. So we're going to say return m_line of sight distance. We're just going to kind of set that up. For has line of sight, we're also going to return m_has line of sight. So get that out. Get current heading, same thing. Return m_current heading. Setters are a little different, and some of them we want to do a little bit more work. All right, so in my set target position, I also have some other setters for set line of sight distance. Let's do that. So set line of sight distance is m_line of sight distance is equal to distance. Okay, we can make that const. Okay, and then set has line of sight. This is where I want to change the color. So when I have line of sight, has line of sight is equal to the state. I also want to change the line of sight color to different colors depending on if I have line of sight or not. So I'm going to say m_line of sight color. Remember, it's a vec4. I'm going to use a ternary operator here, where I check to see what the current line of sight is. And then if it's true, this is the ternary operator, I'm going to make the line of sight color a vec4, and I'm just going to use some basic values. So we're going to say that if I have line of sight, then I want to make it green. Otherwise, that's what the colon means. If I don't have line of sight, then I want to make it red. Okay, that's what this means. So green, red. And I'm setting that line of sight color right there. So this, again, using the ternary operator. So it's like saying if, else, and multiple lines. And we've done this before. All right, so that's it. And then the final thing is set current heading. I want to do a couple things with set current heading. One is current heading, right, is going to be equal to heading. And M underscore, I also want to change direction as soon as I'm done the current heading change. And let me explain what that is really quickly so you don't lose track of what we've already done. We've already kind of done some work here, and we're just adding on to it. So change direction, if you scroll down here, it actually calculates the new direction vector based on the angle that you feed it. So if I have an angle of 30 degrees, it'll calculate the new normalized vector coordinate, which is like where it's pointing. What's the normal for the direction? That's what it's calculating. And it'll store it inside of current direction. Okay, this is important. So that's what this does. All right, and every time, that's why it's great to have these little setters. Setters don't just set values to data, they also can do other things. So that's what I'm using this as more of a method than a setter. All right, so this is all prep for what I'm doing because I want to be able to have color changes when I have collision detection and so on. The next thing I want to do is I want to be able to draw my line. All right, so I want to draw my line. So up on the draw method is where I'm going to put in my new line. I want to draw kind of the line of sight line. This is my debug line, if you will. Eventually, I will hide it. But for now, what I want to do is I want to use the util library where we have our drawing methods. And one is this draw line, right? And I want to start, it says the start position is where I want to start. I want to start from the center of my my ship. So it's going to be get transform. And it's going to be position. That's the center of my ship. And then to the end. Okay, let's think about this. Again, I want to start at my position, my get transform dot position. That's where I'm going to start. So I'm taking that initial, so both the start and the end are the same right now. And then I'm going to march along my current direction vector. So get current direction. That is my normal vector. I'm adding that, which is like, you know, some value between 0 and 1 on each the X and Y axis. And then I want to multiply it by M underscore line of sight distance. And I want to change the color so that it is the right color. Notice that the draw line also takes a color. And I'm going to pass in a vec4, which is my M underscore line of sight color, which I just defined. Line of sight color. Okay, so that's what I'm passing in there. So that's going to draw the line, depending if I have line of sight or not, you know, for the distance that I want, whatever the distance is. I haven't defined a distance, but I'm going to do that now. All right, that is the draw line function. Pretty straightforward, right? So again, I'm going to draw a line from, this is from the ship's middle position. I'm taking the ship's middle position and adding in the current direction vector multiplied by some distance. Okay. Let's talk about this for a second up here. In my constructor function, let's do some more initialization. So I'm going to do some stuff for my line of sight. So in my constructor, I'm going to say line of sight distance, that's going to equal to something like 400 pixels. Okay, just for now. Which is really like saying I want to take, remember I said this in class earlier, I want to take a kind of a ratio of 5 pixels per frame multiplied by, let's say, 80 feet of distance. If every foot on my screen is 5 pixels, I want to go 80 feet long. That's how long or how far away I can see right now. You can make this change later on, and we can use IMGUI to change the distance, the viewing distance as well. All right, and then M underscore line of sight color, let's set that up as a default value, GLM vec 4, or make it red starting off, right? Because we're by default, we don't have line of sight. We'll just start it off with something for now. Because we're not checking line of sight. We're not setting line of sight. We're just doing this. All right, and if you run it right now, just as is, you should see a line that pops out from the ship. It's going to be a red line, and it's going to be hidden behind the, if we have everything good, get grip position is not a member of ship. Sorry, I have more errors. I forgot. Once I deleted that from the ship, then I got a few more errors that come over here. Let's just get rid of these. So this is in the I am GUI part. So what we want here is instead of get grip position, we want to go get transform dot position. We're still going to use this get transform dot position dot x, and we want to do get transform dot position dot y for the ship as well as for the target. Okay, so we want to do that because there's no more grid position. There's dot y, and I want to do the same thing over here for the M target. All right, so that's going to be there, and that's going to be there. Sorry, I had to make those changes because we don't have a target position yet, but we will. All right, and these are all wrong, and we're going to fix this in a second. Make sure this says lab 6, not lab 5. And this could be null pointer, not a problem. Okay, let's find out how this works and everything, if everything works now or not. So we should have a line and should be occluded or behind the other thing. So we should have a line like this. So we want to make this line show on top of this, right? So to do that, we can change the order or the order and layer of my ship. And when we add child, one thing we've added in the last iteration of our framework is we added the ability for us to do an order and layer or a layer index, which we can put to 2. And then if I was to run this thing again, you can see that now we're going to see the red line, and it's going to be on top of the obstacle. So it looks like this, exactly what we've drawn for the most part here, this kind of thing. So we've done this situation. Okay. See? All right, cool. We have our start. It's not a bad start. Let's put this up on GitHub. So if, just in case you had trouble following me, or if I went too fast, or if yours looks different than mine, let's put this up. All I did was I cleaned my project, clean project, and added debug line of sight line. That's all I did. Okay. Commit all, home, sync, and push. So you should have those details up on our final version. So you can compare mine with yours. Okay, are you with me? Check mark if you're with me, X if you're not. I got a couple check marks, and I got no X's so far. Hopefully you guys are up to speed. I'm just slowing down to get you a chance to catch up so you can see what I've done here, right? All right. Does anyone have any issues? That's the first part, because without this, without getting to this part, then the rest will be a little bit more challenging. All right, what I want to do now, and again, this is a little different than what I did earlier today, but you know, learnings. I want to be able to rotate my object, my ship around the scene. So, and I want to be able to move my ship and my target around. I want to do that right from the beginning to give myself a lot of leeway in terms of testing. So what I want to do here is I want to scroll down to the I am GUI function, the GUI function right here. That's in the scene. I want to change a couple things. I want to add a underneath the lab 6, directly underneath that, I want to add a new angle. So I want to say something like, let's have a static int that I'm going to call angle, right? And I'm going to say that if I am GUI, slider int, there's slider int. I'm going to use an int for this. It's going to be the ship direction. That's what it's going to be called. And I'm going to go with an and angle, right? From -360 to a positive 360. Okay, so that's what this is going to do. If there's a change to my angle, then what I want is m_p ship. I want to set the current heading. Remember we just did that function? Set the current heading to that angle, whatever that angle is. Okay, so that's what that's going to do. So this is going to change the ship. This is going to allow me to rotate the ship. So allow ship rotation. That's what it's going to do. And I want to set up movement for this part. So this is incorrect. Start position is good. 0 config. As an example, this is called start position. We'll call this the ship position, right? And let's rename this, refactor rename, to the ship position, just so that we're accurate. So that's what this is, ship position, target position, right? And my ship position is going to start off at 0, from 0 to, let's say, 800 for each of the dials. So 800 is going to be the kind of upper value. And the same thing goes with my target from 0 to 800. What I need to put in here is m_p ship, and I want to get transform, and then position.x is equal to my ship position 0. Remember we did this last time? And I want to do the same thing with the y value here, where I take the y value and I want to use 1. So this is kind of whenever I move my ship around, the x and y position will change when I change around the dials. And the same thing goes, just going to copy paste here, with the target. So target is going to be here instead. And instead of ship position, this is going to be the target position. Okay, so that's the only thing I've changed. So I'm doing this in IMGUI because we need to test thoroughly, rigorously. And I want to set up my test framework nicely so that I don't have to work hard later. I'm setting it up now, I'm paying for it ahead of time, because I found when I did it in the first time, it took a little bit of more time to do this, and I can just get it done and it's over. All right, let's check it out and see if I can move my stuff around. So run, and we should now be able to see an IMGUI come up. There it is. I can move this around. And if I rotate this, I can rotate my ship around anywhere I like, from positive 360 to negative 360, right? So not freely, but anywhere I want in that range, right? And I should be able to move my ship around anywhere inside of here, up or down my scene like I want, to give myself control. And this, you'll use this for your screenshots, okay? So I can move my stuff around. Great, let's put this up on GitHub. So again, Team Explorer Home, I want to go to changes, and I want to say that added debug kind of inputs to IMGUI. Here we go. Home, sync, and push. So that's going to have everything you need to get your debug stuff working. Okay. Again, we haven't turned off and on the line, but that's something else. Your renderer isn't clearing, then that means that you missed this part right here, where on the draw area of the play scene, I moved the order of my draw display list from before my if statement to after my if statement. Do that and you're good for now. Okay, Sean? And it should be right. All right, next. So now that I have this, now we can do the real work. That's just all the prep work. So let's get into the collision detection algorithm. What we want to try and do is look and see what we already have. This is the main thing. So my managers, if I go to my collision manager.h, you can see that I have several different collision manager stuff, like collision detection algorithms. One is a point rect check, where I can check if a point is inside of a rectangle. I've got a circle AABB check, a circle AABB squared distance, a line AABB check. Yes, I used that before, but I don't want to use it now. I just want to use a simple line rect check. This is the one I want to use, but I want to make my own. Let's make my own, and let's think about how this is going to work and what I'm going to do with it. Okay, so I want to call this a static bool. We're going to detect if it's on or not. We want a line of sight check, right? And the line of sight check will be between the start point. I'm going to have an end point for the line, right? So I'm going to have a vec2 start point and a vec2 end point. It'd be nice if we had a line. We don't have a line. We're going to do this, start point and end point. We're also going to think about basically looping through a display list, and I'll talk about this in a second, a const standard vector of display list objects, right? That's what we want. We're going to call this objects in the scene objects. And then what we're going to have is the target display object that we want to include. So display object pointer to this thing called target. So it's kind of a longish line, but it's really, just going to see if I can include all of it so you can see all of it in there. It's just this. There we go. And that I'm including this new line in the collision manager. So what does this all mean and why this vector of display objects? Well, let's think about the use case here. So, and when you're done kind of taking this in for a second, remember that we have these display objects. I have a display object here for my ship. That's a display object. I have an obstacle. That's a display object. And I have a target. That's a display object. And what I have in my scene, this is what we set up in the scene right now, is we have a display list. So here's my display list, right? And I have a bunch of objects in the display list, right? The display list is just a vector of display objects. So I have all these things listed. So I might have my ship, depending on how I add things in, it might look like this, ship, and then I might have obstacle, right? Here's my obstacle. And then underneath that, I'll have target. Let's suppose I have these. Okay, so ship, obstacle, target. Okay. So what happens is when I add things to the display list, then these things are rendered in the scene. So let's suppose the scene, again, is going to be this kind of rectangle that I'm going to draw right now. So here's my scene. Okay, so this is what the thing will look like, right? And these things are going to be rendered. And every frame, what's going to happen is I'm going to update the display list. I'm going to draw the display list, and I'm going to update the display list. So draw and update, okay? Different functions. That's what I'm doing here. This is great, but what if I have another target? Like, for example, something that's out here, or another obstacle over here, or another obstacle over here, or here. How do I know that this line is going through this particular obstacle and not these ones? I don't. That's the answer, right? When I do collision detection, I need to do collision detection with every object in the scene. I'm not doing ray marching. I'm not marching along the line, kind of stuff to kind of look at every single point in the line. I'm not doing that right now. That might be a future algorithm we do, which is more accurate than what we're doing here, okay? All I'm doing is taking this line and saying, can I collide? If I collide with anything that's closer to the ship than the target, if I collide with anything that's closer to the ship than the target, then I do not have line of sight. Okay, so that means that I'm going to make a second list. I'm going to get a list of contacts, let's suppose, that makes sense. Here's the things that we want to make sure. That if the distance of my ray, which is the line of sight distance, if it's some object way over here, okay, as an example, let's suppose I have an object like way over here, we don't care about it because it's outside of the distance of my ray, all right? So we don't care about, let's make these red lines. We definitely don't care about objects that are over here, okay? We don't care about those objects, anywhere over here. We don't care about objects really at the end of the day that are behind the, the thing that it's pointing to. So we don't care about objects over here as an example, but we do care about all these objects. Okay, there's also another case where if this target, as an example, if this target, I'm just going to copy it here and paste it. And I'm just talking about how we're thinking about this right now. Okay, this is not the only way. Like I mentioned before, please do not think it's the only thing we can do. But let's suppose I have my target, and instead of being over here, let's suppose my target is here. Well, I don't care about anything that comes after my target. All right, so that is also something I don't care about. I don't care about anything that comes after my target, anything that's over here. I don't care. Right? Anything that's on this side of the behind my target, I don't care about. Why? Even though there's still line of sight distance left, this line is pretty long, let's say, right? We really don't care if my target is closer and there's nothing between my target and my ship. I don't care about the other stuff. So those are things we don't care about. So we can do a little bit of partitioning here when it comes to doing some collision detection. All right, so that's something that we want to put in our line of sight check, okay? We want to think about those kinds of things. So let's start coding and think about how this is going to work. So again, I'm going to go here and I'm going to go to, I wanted to create this declaration, generate my implementation. So this is where it's going to start. And I'm just going to keep it on one line if possible, just so that way, you know, it looks like this. I'm going to hide the solution explorer here so you just can see this part. It's telling me that objects should probably be a tidy little check, which adds the ampersand, so it passes it by reference. I'm okay with that. And what I want to do is I want to start thinking about looping through all the objects. I want to loop through every object that I'm going to get. I'm going to get a list of objects that I'm going to feed this line of sight check. Okay. I'm not going to generate the objects. I want to feed this thing with a list. I'm going to feed the list an object of display objects. That's what it's going to be. This is display objects, right? And let's assume I have the list. And let's also assume that the last item on the list is my target. I want to sort the list so that the last thing I check is my target. Okay? I want to check everything else, and the last thing I check is my target. Let's think about this. So I want to do a for loop. I want to do a for each. And a for each in a C++ is a range for loop. So we're going to say that this is the game objects that we're looking through. We're going to make this auto. We're going to call this for every object in game objects, object in objects, right? So there's the objects vector or list, right? Equivalent. And I want to loop through every object in this objects vector, right? And I want to do some pseudocode here. Let's do some stuff. Let's check if the line collides with an object, right, in the list. Does it collide with anything? Okay? And the way to check that is if we do that line check. So the first thing we do is we say if line rec check, because line rec check does multiple lines. If you look at line rec check, that's already been written for you, right? And if I scroll up a little bit, right? So line rec check, which is way up here, it basically does 4 line checks. Line check, line check, line check a bunch of times. Okay? So I do 4 line checks for every time I do a line rec check. Why? Because I check each line in the rectangle, right? To see if I'm colliding with the line from start to finish. That's how line rec check works for the most part. All right, cool. That's what I do. Line rec check. It takes a start, right? So I'm going to pass in the start point, and I'm going to pass in the end point, which we already have coming into our parameters here. Line of sight check. I'm going to get start and end. This is our line segment. Okay, that's what this is. Again, it would be nice. And whenever I say it would be nice, I'm always thinking about, can I make a line class that gives me a start and an end point, and then I can just pass in a line here instead of this. That would be nice. Okay, next. Let's also transfer in the object's position. So I'm going to say that, hey, for the object, I want to use its get transform dot position, the position of the object. Remember, this is centered. And this is the position I'm going to use for the rect start. Rect start means the top left corner of the rectangle. That's what it means, top left corner of the rectangle. This is not the top left corner of the rectangle. This is the middle of the rectangle. I need to march back half a width and march up half a height. So I'm going to say that I'm going to subtract the GLM vec2 object, which is the offset that I want to. And by the way, before we do the subtraction, let's just calculate the offset first, because we have lots of room to make other additional variables. It's not going to hurt us. So if I calculate the object offset as, that's going to equal to a GLM vec2 object that's going to march back the object get width multiplied by 0.5 and the object get height multiplied by 0.5. That is my offset, right, that I'm going to use, the object offset that I'm going to remove from the original position of the object, because the object, remember, it's centered, and I want to march back and up, which is what this is going to do, this object offset. So I'm going to do that. Object offset. So I'm going to subtract object offset. So that's going to be my start, my rect start. And then I'm going to plug in my width and my height. Object get width, and then object get height. Okay, so that is everything I need to see if I've got a collision. So do I have a collision? That's what it tells me. Check if the line collides with an object in the list. Okay, whatever, all the objects in the list. I'm checking every single one. If I have 1,000 objects, I'm checking them all, right? Because that's the simple little collision detection we're going to do right now. All right, next, what I want to do is I want to say that if the collision, right, if the collision is with the target object, because we've included it in the target, then my line of sight is true, right? If the target that if I'm colliding with an object that's the target, right, then return true. Okay. Remember that the target object is the last object on the list. So if I've got to the target object, that means all the other objects we've checked beforehand, right? Because I'm feeding it an ordered list. Okay, I haven't done it yet, but I will. So get type. I'm going to check if the type is equal to the target. Get type. And remember, type is basically an enumeration that tells us what the object is. It's like a name, but instead of typing in a string, we're using an enumeration, right? And what I want to do is I want to immediately return true if that the object that I'm checking, the last object that I've checked, this is the one, right? Otherwise, if I did a line rect check and it's something else other than the target in the list of possible display objects that I'm checking, that must mean, my friends, that we don't have a line of sight, right? So what I'm going to say is that below the if statement, this if statement right here, I'm going to say that if the line collides with an object in the list that is not the target, then no line of sight. Okay? Line of sight doesn't exist. So, or we can say then line of sight is false. Okay, which is what we want to say. And we can just return false here. So this is one case. The other case where we want to return false is, as an example, what if I don't have any collision at all, right? So somehow this line doesn't collide with anything, not even the object, all right, as an example. So that would be bad too, right? That means maybe the line, the length of the line is, my target is beyond the length of the line. That's a case that could happen. So somehow, you know, in my code, instead of putting my target here at the end, what I've actually done is, let's just generate this so you can see it, right? Sorry, go do this again. Imagine if I have my target, but instead of being here, instead of being here, I move my target. Oh, let's try that again. Sorry. Let's try that again. And I think I may have to squeeze down stuff. Yeah, good. Yeah, for sure. Let's just do this. Merge all. Sorry. I think you get what I mean. But I'm not assuming anything, so that's why I'm doing this. So imagine if I have this and my target's way back here. Or what happens if that's the case? So it's not here, it's way outside of the length of the line. So that means that I may get it might be an opportunity where it's just outside of the range. It's outside of sight range. I can't see it. It's too far away. Okay, it's not an infinitely long line, is what I'm saying. So that is something that is else. So I don't care about objects that are past the target, right? If the object's past the target, Ethan, I don't care. The target is what I want to have line of sight with. I don't care about other objects, really. So I have to really be, careful here. So that means if this fails, this is false, then there's no rec check. It doesn't do anything. And let's suppose I leave this list somehow without doing any kind of collision detection whatsoever. Then what I want to say is return false by default. Okay, so that is possible as well. So if the line does not collide with an object at all, that's possible. That is the target. Then line of sight is false. Okay, so if the line does not collide with any object that's a target, then line of sight is false. So we know that those are the cases. And that's my line of sight check. Now, there's still pieces that are missing. Am I sending in a list of objects in the target? Well, I've got to really do a little bit of pruning for my list. That's a very good question, right? Because I got to figure out how I'm going to give this. This is where we can kind of make some algorithm improvements here. I want to send in something to this line of sight check because this is all it's going to do. It's given a good list. That's the assumption. Let's make some assumptions here. So that's why I'm making assumptions. Assumptions, right? The list of objects are stored so that they are facing the target, right? And the target is loaded last. That is what we want to say in the list. Okay, we don't want anything in the target. We don't want that first thing to be first, because if it's first, then we won't check through each of the items. We're just going to return if it's first, right? So we want it to be loaded last, right? So yeah, so that is part of the thing that we're doing. So that's the line of sight check. Okay, so that's why we're saying let's load this last. Okay, so that's one thing we have to. So this list has to be pruned properly or ordered correctly. If it's not, this thing will fail. Okay, so that's a couple things. We've got some dependencies, if you will. Okay. All right. Excellent. We've kind of started with our first simple check, right? And now what we want to do is we want to make use of this thing inside of our code. So let's go into our scene. So where we want to make use of this is at the top of the scene. So if I go to the playscene.cpp and scroll up, you can see that I have a draw and I have an update. Right now, our update method, right, all it does is update the display list. But one thing we don't have access to is we don't have the display list itself. I need to get access to the display list. So unfortunately, right now for our code, if you look at our core and if you look at scene.h, there is no, I have a display list here. Here it is, but it's a private member that I have no access to. I need a getter for this. Okay, I don't want to set my display list, but I definitely want to get my display list from the scene. Okay, so this is something that I want to be able to do, and it's a new feature of my scene, right? So what will this look like? It's going to look like this. I'm going to say that standard vector, right, of display objects, pointers. We're going to call this get display list. Now you're going to say, wait, Tom, if you're exposing the display list like this, why even bother making this private? Again, remember getters and setters? We can always do other things in here other than that, right? Typically, we don't want to do this, especially for some kind of collection like this, but in this case, it might serve us. All right, so get display list is what I'm going to do. I'm going to go here and we're going to generate my implementation. Here's my get display list. And what I want to do with the get display list is literally, it's so easy. It's going to be return m underscore display list. So I'm returning a reference to the display list itself. And it's saying, hey, make this const, right? Make it const, because you know what? We're just going to display a constant list, which is okay. I agree. Let's make it const. So this is going to return from my scene, my superclass. That's the superclass, the scene of all scenes, if you will. Or the class, the scene class of all other scenes. All other scenes depend on this one. I'm going to make it so that I can get the display list of any scene by just saying get display list. Save. Save. So then, what I want to do then is inside of my play scene, I'm just going to save everything so we're ready to go. So in my play scene then, what I want to do is start thinking about my algorithm. What is it going to look like? And how am I going to separate this out to make heads or tails out of getting my my class working, right? My line of sight. So one thing is I want to do something that looks like this. I want to say that, look, if my ship distance, right, which is my ship to target distance, if my ship to target distance, right, if it is less than or equal to my line of sight distance, if ship to target distance is less than or equal to the line of sight distance, the one that I've stated, 400 pixels or whatever, only then do I want to start detecting if I have line of sight. If it's outside of this distance, I don't care. That's that pruning I talked about before, which is if I go here, I don't care if it's outside, it's beyond this point over here, way over here. Or if I'm pointing, wherever I'm pointing, way far away. I don't care if it's far away. I only care about stuff that's close or that's within line of sight distance. That's what I care about. So that's the first step. So I'm going to just type that in. So I'm going to say if, and I want the ship to target distance. And let's use a bit of a utility for this. So I'll say auto ship to target distance. Again, we're going to pull this into a method in a second, is equal to, or later on, is equal to util distance. Again, I'm using square root here, but that's okay. M underscore P ship. And I want to say get transform. So this is the first thing. So P ship get transform, right? Position. And then I also want to go M underscore P target get transform dot position. So that's going to be the distance between my ship and my target. And we're going to call this the ship to target distance. I put it on a separate line here because I don't want it to type this, and then do an if statement with that. I'm just going to go if ship to target distance is less than or equal to my M underscore P ship, and I want to get the line of sight distance. If it's less than this, then and only then do I want to start checking. If it's not less than this, who cares? It's far away. It's too far. Okay? Now, I want to make a temporary contact list, a list of contacts or objects. So I want to make a list of contacts, which I'm going to call a display list array. So contact list is what I'm going to make. Standard contact list, right? And I'm going to say for each, again, for each, and what I want to do is I want to use the get display list. So I'm looking at all objects in the display list. Okay, I'm going to use the term object again. So for auto object, for every, this is how you read this, for every object in the display list, right, I'm going to loop through each object in the display list, and then I want to start comparing stuff. I want to say that here's my next check, right? If my ship to object distance, right, if my object is farther than my ship to object distance, ship to target distance, right, then I don't care about that either. So check if the object is farther, than the target. So if the object is farther than the target, farther away than the target from my ship, I don't care about that one either. That means, if I go back to drawing it, this case here, that if my object I'm checking, this obstacle here is an example, right? If it's farther away than my target from my ship, I don't care about this or this or this or anything else up here. So one thing I don't care about this, the first pruning I did was I don't care about this part, right? So this part, I definitely don't care about anything past my my distance. I don't care about this part. And the next part is, what if my target is closer to my ship than some obstacle? Well, then I don't care about the stuff that's inside here either. I don't care about that stuff. All I care about is if my whatever's here, right? So between my ship and my target. If something is closer, if there's another object that's in here, I do care about that, right? But anything that's outside of here, if it's farther away than my target, this is a case, right? Then I don't care about it. Okay? We're going to be calling it regardless, but we're going to be trying to prune or reduce is what we're trying to do. Okay? So that's what we're trying to do here. So check if the object is farther than the target. So to do that, then I want to make an auto. And again, I want to do a ship to object distance. So whatever the ship to object distance is going to be the same util idea, util la 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 la. But instead of ship to target, it's going to be ship to object. So my ship to object distance, what's the difference? What's the distance between this and this, right? And then I can say something like, okay, cool. Well, if the ship to object distance, right, is it only when it's less than or equal to the ship to target distance do we care. If it's not, if it's outside this bounding area, we don't care about it. All right. Next, I don't want to load my ship inside of my list. I definitely don't want to load my ship in my list, and I definitely don't want to load my the target in my list until the end. I don't want them. Remember, the target's got to be the last thing I load. So I'm ordering it, kind of by hand, if you will, right? So I want to say something like, hey, first let's check to see if my object, right? I want to say that if my object get type, is not equal to the ship, because that's also part of the list, right? My ship. So if it's not the ship, that's good. That's what I'm saying here. All right. And if the object is not, if the object is also not the target, that's also good. Now you can write this on one line, right? Because I want to say that these two things are the cases, right? So these are both true in order for me to do something in here. So instead of writing it like this, I could write it like this, right, is true. This is true. And let's make a bracket. Let's add another bracket in here. Okay, so I'm going to just surround these with brackets. Wrong bracket. I want to surround these with brackets, and I want to say if this is true and this is true, right? That's true and that's true. Then we don't care about this. We only care about if any one of these things is true. If it has both be true. But it can't be the ship and it can't be the target. If it's the ship or the target, skip. All right, and we want to say that contact list dot push back the object, whatever that is. So that's how we're going to form out our list. So we're going to go through, check each one, make sure it's the right distance, and then form out the list this way. Okay, so we're adding each object to the list. Right now there's only one, based on distance and the fact that it's not either the ship or the target. Okay. And then finally, after we loop through everything, right? After we loop through everything, and we're going to, just outside of the for each loop, we're going to add that in. We're going to say contact list dot pushback, and we're going to add in the m_p target at the end. Remember we said that add the target to the end of the list, right? Why? Because if I got there, that means I've checked all other objects that are in reason, and I've sorted everything that I want to sort. Again, this is one way of doing it. Which is kind of, we can check if it's an obstacle, but it could be something else instead. So instead of checking if not ship or target, wouldn't it make more sense to check if the object is not? Well, no, because what if it's not an obstacle, but something else? What if it's an enemy, or if it's whatever? We don't know what it is. Right now we're calling it an obstacle, but it could be something else, right? It's not just one thing. It could be 10 things, right? So we can't just specify to one thing. Yeah. So enemies will also break line of sight, correct. All right, so then what I want to say is that if this is true, then I want to set line of sight to true. I want to set line of sight to true, right? Because the first thing is this is setting up our list, and I want to feed this list, this contact list, into the line of sight checker, okay? So in order for me to do that now, I want to do the collision manager. So I'll say, hey, collision manager, I want to do that line of sight check stuff. And I want to pass in the start point, the end point, and I want to pass in the list as an example, and the target. I want to pass in all those things. All right. So what is the start point? Well, we know it is the ship. So it's m_p ship, right? Get transform dot position. My endpoint is the ship's position plus the distance, as an example. So I can say m_p ship, and then it's get transform dot position, right? Plus I want to get the direction of the ship, m_p ship, and then get current direction, this one. So that's the direction vector. That's what this is, multiplied by the line of sight distance, m_p ship, right? Get line of sight distance, all right, multiplied by that. I want to put this on another line so you can see it on separate lines, right? So that is the start and end points, right? And then finally, it's going to be the display object list, which I just made, which is this thing that says contact list. That is what I'm passing in. Finally, and also the target, which is m_p target. And that should give everything I want to the line of sight check to the collision manager. The line of sight check is actually going to return a Boolean, which I'm going to take in. I'm going to say that auto has line of sight is equal to this. Okay, that's going to keep track of it just to make it separate. I don't have to, but it's easier than doing this. m_p ship, and then set has line of sight to has line of sight. Instead of planting that in there, like all of this and here, I'm just making it a separate variable so you can see it. And that, my friends, is the algorithm. Okay. Now it looks like it's complex, but actually it's not. All I'm doing is I'm doing several checks, right? And I'm checking to see if I'm giving you the algorithm too, so you can use it, massage it, make it better, and we're going to improve upon it. Like I said, in the next iteration, we're going to use a different way of doing raycasting altogether. That might be more accurate and more efficient, but a little bit more challenging to figure out and understand because it's more mathy. All right. So this is definitely a way that's nice, that's easy to understand, maybe not the most efficient. All right. Well, we made it in one, but we never checked it. So let's check to see if this works. Remember, when I set has line of sight if I go to definition for this, right? And then what's going to happen is it's going to change the color of the line if I have line of sight. That's what's going to happen. Okay. Let's run it and see if it breaks, first of all. And then we'll take this and put it inside of its own method. So again, remember my motto, make it work, and then refactor. Okay. All right, it's a red line. And what I want to do is I want to put I am GUI up, and let's move the target position closer and see what happens. So I'm going to move the target position over here, and we have a green line. Yay. But also notice that I had a green line in here. Wait a minute. Why? Well, that's okay, right? Because what's happening is I'm actually inside of another object, which is not going to happen in your game. You're going to have other collision detection that you're going to have in here to stop it from being inside this object where the target is actually in the obstacle. That's not normal, right? Okay, what about if I rotate? Let's rotate. No line of sight there. But if you notice, if I'm here, so no line of sight. And if I bring my object, here's my target position. Let's bring it up here. And as I just penetrate this, look, there it is. There's line of sight. Pretty good, right? But if I take my object and I move it away, once I move it outside of that bounding box, remember it's a square here, not a circle, then no line of sight, right? No line of sight. And or if I rotate it this way, right here, let's rotate it this way, and let's move the ship position down here and move it behind the obstacle. No line of sight, no line of sight, right? But if I rotate it this way, and if the target comes over there, so let's try that target over there, right? And then move it down in there, then line of sight, line of sight, line of sight works. Okay. That's what we want today, guys. If you're here with me, you're good. I want you to take screenshots, a few screenshots of different positions, showing where line of sight does not work and where line of sight works with one single target. But what if I had more than one object? Does it work with that? And we'll come back to that in a second. First, let's optimize. This does not belong in the update method. This is like a big, massive, kind of, piece of code. And I want to put this, I want to extract it with refactoring inside of its own method. Let's do that. So again, I'm going to highlight everything, right click. This is one way of doing it. Going to refactor, and where it says extract, I want to extract the method. It's going to give me a method name that I want to use. So let's think about what this method is going to be, right? Maybe get line of sight for ship, or check line of sight. Check if ship has line of sight with target, right? Something like that. Now this is very specific, right? So where I have line of sight, check ship line of sight with target. That's what this thing is. Exactly that. Nothing else, right? So again, you may want to change this. Check ship line of sight with target. Very specific, right? Now you can make this more generic. I can say check ship line of sight and pass in the target. And that's definitely what I want to do. Whatever the target is going to be, I can change it up, right? So I can check the ship line of sight with something else. So let's say check ship line of sight for now. And then we'll massage this and make it better. Return type is going to be void. We don't care about it having return type right now. And we're going to click on, it says that identifier is not valid. Check ship line of sight. That's the name. Maybe I've used it before somewhere else. Check line of sight. We'll just say check line of sight. Call it that for now, and then I'll fix it. Oh, the brackets. Nah, maybe it is. Check line of sight, or we'll say check ship line of sight. Yeah, I put the brackets in there by accident. Okay, good. There we go. I definitely want to make the it going to be void, and I'm going to click next, and then it should generate that method. There's the update. Look at that. Check ship line of sight. So the update stays clean. I've got this check ship line of sight up here. I want to put it like a little lower or somewhere else, but because it's around my lifecycle functions, I don't think it's a good place. So I'm just going to cut this out for now and put this somewhere else outside of my lifecycle functions, like somewhere down here would be good. Okay. Let's also do some massaging to this. So I'm in my placing.h, right, where I have my check ship line of sight. Let's take this out of here, and it's a public method. Maybe it shouldn't be public because I'm not going to share it. It should be private, right? And let's do a couple of things here. Let's massage this so it is what it is. I'm going to refactor rename. So it's m underscore check ship line of sight. And I'm also going to pass in a display object to check. So this is a display object pointer, right, where I'm going to check with whatever it is, object. So check ship line of sight with whatever the object is. Okay. I want to take this piece here because ours is a different implementation of this and fix it. So going back to here, scrolling down to where I have this and putting in this. All right. Check ship line of sight with an object. The object is going to be something that is called object, just like this object. So I need to make this something different. We'll call this the, kind of the target object. So let's make this target object. Okay, here's my target object. And if you don't like this, we can also go target object, just to make it nicer. Target object, right? And instead of the ship to target distance is with m underscore p target, we want to say that this is going to be the target object get transformed. So this way it's more flexible. Same thing with this target object, right? And this target object, right? And this, anything that has m underscore p target, you want to change it. Make sure when you go through, I don't want to do a kind of find replace. I'm just going to go do it by hand, make sure that I've got everything. Looks like I have. And this is also limited because I'm checking ship line of sight. Maybe I want this to be part of every ship, every enemy. So therefore, if I wanted that, then I'd have to put this inside of the enemy class to check line of sight. But I'm just showing you how to do it with one object at a time. All right, cool. So this is great, but I need to modify this now because I have an error. Here in my check ship line of sight, I want to pass in m underscore p target. And then this should run the same way. And this looks nicer too. I'm checking the ship line of sight with the target. Okay, so let's see if this works. So again, more human readable, a little bit easier. And I'm doing this after the display list, and I'm hiding it from the display list. I don't pollute the update function, which is all good, right? And let's move this over. So instead of 600, we're going to say that it still works. We can still rotate stuff. It doesn't work. And we're going to move this up here so then it works, right? It's all the same functionality. Line of sight is good. Okay. Great. I am happy that we got this part done, right? Now, from a screenshot perspective, like I said, for this lab, what I'd like you guys to do is make sure that you take a screenshot of different positions on the screen, and we have line of sight. A couple other things to do is, what if we check different obstacles? Let's say we have more than one obstacle in the scene. So we can check to see if we have line of sight with different obstacles, and let's see what happens. Because one obstacle, well, that's easy to do. What about multiple obstacles? What does that do, right? So this will really check our algorithm and if we have a problem. All right, let's try this out. So again, in my placing.cpp, we have one obstacle. Okay, one obstacle. And remember, it doesn't matter how many obstacles I have, right? If I want to have a list of obstacles in the scene or more obstacles, we can do that. Let's just add in a couple more. So again, I can make it an array of obstacles, or I can just say obstacle 1, 2, 3. For now, I'm just going to do obstacle 1, 2, 3 because I'm lazy. Obstacle 1, obstacle 2, obstacle 3. Okay, Obstacle 1, 2, 3. Okay, and in my place scene now, we have a couple more obstacles. This will be obstacle 1. And what I want to do is I want to add more obstacles in different places. So let's try this out. So here, we'll say obstacle 2. So we know where this is. This is going to be at, instead of 400 and 300 in the middle, we'll make it at 400 and 100. So this is kind of above it. And we'll make one below it so we can see different obstacles, maybe one to the kind of closer to the bottom end. Again, you can make them whatever you like, right? Try them out. And we can also procedurally generate these things so that they're more than one obstacle. Instead of ship, it should say obstacle here. Okay, and this will be, instead of 400 at 100, we'll make it so that it is 600 by 500. So below the other one, below the target. 600 by 500. Okay, let's see what happens if we try this. Remember, do I need to have any of these things mapped anymore? Well, no, because it's going to be all added into the display list, right? So let's see how this works. Does it do what I want it to do? What does it do? Yes, I got a few obstacles now, one above, one below, one over here. And it looks like I have no line of sight. If I was to turn, let's put IMGUI down here. Let's turn my ship around so it goes this way. And let's move my ship up again. So on the y-axis up here. And let's put my target up there too. So we're going to move this up here and across. No line of sight, right? That's how it should work. So even though there's more than one obstacle in the scene now, no line of sight. When I turn and I move this thing over to the on the x-axis to here, then line of sight. Okay. What about if I have multiple objects that are occluding? Is that possible, right? Right now, it's kind of hard because of the way I put it. What about if I put my ship something like in here and I'm hitting two obstacles at the same time, or something like over here? So let's try this out where I move this down. So I'm going to take my target position and move it down the screen, let's say somewhere like here and a little bit more to the left. So somewhere in there, and then move my ship down. So again, we're just trying to, test to see if this works okay. Sorry, wrong one. And if I was to change my position, you can see that no line of sight. Okay, that's good. Okay, no line of sight there. Between obstacles, I'm definitely colliding with these ones, right, as an example. And let's put my ship position up a little bit again. Right? Still no line of sight. But if I rotate, line of sight. Nice, nice. So we know it works. And we should also try it in different positions. So for example, maybe we'll try this one down here. So let's move my ship position down, way down here, right? As an example, see that we went too far away. It lost line of sight. And let's move my target position down. So target position down. Still no line of sight. Still no line of sight, right? And it doesn't matter where it is, but if I move my ship out from behind this thing, so let's move my target position. Let's move my ship outside of there. So ship on the x-axis, move it out, and then re-angle it. Do I have line of sight? Yeah, I do have line of sight. It clips it nicely. Okay, so again, doesn't matter how many obstacles you have in the scene, you can make it work. This is good. This is why we want it to be like this. We want to be able to say, I don't want to tell how many obstacles are in the scene. I want the display list to find all the obstacles that are relevant. Anything that's far away like this one, I don't care about it. I only care about these two because this is closer. This is within range. This one here is being culled. I don't care about this one. And this happens every frame, by the way. Every frame, every frame, every frame. I'm doing it. And the performance isn't terrible. questions around this line of sight, which is a very simple way of doing it. I'm going to put this up on GitHub for you guys so you have access to it all. And any questions, comments, would you do things differently? Well, how are you thinking to do it? You know, these are kind of things that I would ask. So changes, and I'm going to say that first draft of line of sight completed. That's what it is. Commit all, home, sync, and push. That's up on GitHub for you. Well, there's other issues, right? What if I have multiple objects that have line of sight? For example, every enemy has line of sight. Then I got to do that check, that line of sight check multiple times, right? So right now, the way we have it is just the ship. It's just the ship, right? And this check line of sight stuff, right? I'm getting the target. I'm passing the target in. I need to be able to pass not just the target, but also I should pass for every object. If I had multiple ships in the scene, right? Multiple ships, then it says, should I have more targets as a vector? Sure, I could do that. But for every target I have, I can have the check ship line of sight with multiple targets. I can do that. I can check ship line of sight for each target, right? Nikolai says a game object vector. Yeah, there's lots of stuff. I mean, that's just like if I wanted to make this nicer. I've just got like three obstacles that I said 1, 2, 3. I could add in multiple obstacles in here and make it so it's a vector of obstacles as opposed to obstacle 1, 2, 3. Obviously, right? That's like, you know, kind of an obvious improvement, but that's not what I'm saying. I'm saying this check ship line of sight is specific to the ship, this one ship. And what I need to do, and this is kind of the topic of what I want you guys to practice for next week as we move from line of sight to radius as well. We want to get that sensing suite going because we can't do any kind of decision trees unless we have a mechanism for deciding whether we have line of sight or being able to trigger the changes for our enemies. We can't do that. All right, so we need this first. This is kind of our first steps. Line of sight and a radius of some kind, okay? And that means for each enemy, and if I'm gonna have like 4 enemies on the scene, this can't be here. This is only for the ship. So here's a challenge for you, right? If the ship was our enemy player, right? I want you to think about how do I add this to the ship? So the ship itself is going to have a check line of sight method that is going to be called. For each ship in the scene, it's going to have check to see if it has line of sight with your target. One target, multiple ships, and multiple obstacles, which is really what assignment your requirement is for assignment 3. So for a number of different enemies, they're going to have the full sensing suite, line of sight, as well as radius, single target, which is going to be your player. Okay? All right, so that is what I want you guys to think about. We're going to improve this next week, but we're looking at this right now. Any questions around this at all for today? Otherwise, that's it for today, guys. All right, if no questions, please make sure you do a couple things. Take a few screenshots, make sure your repo is private, share it with me and Alex. That's important. Make sure also that you, no videos, please. It should just be screenshots. And if you don't hand in screenshots, then you get 0. And I agree with that. Alex kind of insists on that, and I agree. I think, if you hand in your repo, but there's nothing, then we really can't prove that you've done any of the work. You should actually at least run it and try it and all those kind of things to make sure it works fine. So that's what the exercise is for labs. Labs should be very simple to do. You follow along, and then it's your homework to try to get you to understand the code. All right, that's what it is. All right, guys, that's it for me. I'm going to stop this recording, and then I'll see you guys next week. Good luck on your lab. Again, your lab is due this Sunday, and then hopefully you'll be able to get it done with no problems. Thanks, guys, and take care.